So, firstly, welcome to the DataSHIELD September's Newcomers workshop. So this is something we try to run monthly. So we didn't do it in August because there was some holidays, but glad to see so many of you made it for the September one. And generally in the course of these Newcomers workshops, we pitch it at very first time users. So if you have ever used DataSHIELD before, it probably will be a bit of a repeat, but maybe that's good. Maybe that'll reinforce something that you need to know. Yeah, I'm Alex Westerberg. I am a research assistant at Newcastle University. My colleagues Dimitri and Elaine also work as part of the development team. So, what's it doing? So, before I start talking about what is DataSHIELD, could I ask you once more to go to Menchie.com? I'll change my share. And what we're going to do is just quickly gauge what your experience level is at R and DataSHIELD. So I think that's the same code, is it? Compare with the chat.
I think it automatically goes on, flicks onto this screen on Menchie. So we're good to go.
So which can you see now? Oh, right, okay. It's telling me voting is closed. Is that the case for anyone?
Oh, yeah.
Yeah.
Let's fix that. Customize, close voting, try again.
Yeah.
Present.
Yeah.
Oh, thank you very much for being so quickly responsive. That's nearly up to the number of participants we've got. So yeah, this is just going to show that you are at the right session. So we are using some like some already expected R knowledge. There's lots of stuff in the R script. So what I can do is tell you how that converts into a knowledge of DataSHIELD and DataSHIELD syntax, etc. So yeah, that's still running if anyone still wants to submit, but I'm going to switch screens again to the PowerPoint. Thank you for your answers. If I share that, can you see what is DataSHIELD?
Yeah.
Perfect. So, well, what is DataSHIELD? In the most basic terms, it is a tool for analyzing data that you can't directly look at. So there's various reasons that you might not be allowed to look at it, such as patient confidentiality in medical circumstances, or perhaps intellectual property protection in business circumstances. But regardless, it is a restriction and you must work around it. But luckily, DataSHIELD provides a ready-made way to do so. In DataSHIELD, the way it works is you request a result to something you're querying like mean or variance, and it's set up at the server end to decide whether or not that result is too revealing of the low-level detail. So you're blocked from seeing the result if it is too revealing, and the algorithm will decide that. This method we call active disclosure protection, and it's very useful to give the data owners and custodians confidence that their data is not going to be misused. Another feature of DataSHIELD is its ability to remotely co-analyze the data, especially when it's spread around the world. There's several consortia with data sets spread around different German hospitals I've heard of. So the data will be stored at those hospitals. The commands will go from the analyst's PC to those computers. So the commands go to the data, and the data isn't put at risk by being transported either digitally or physically to the researcher's computer. So this is known as federated analysis, and it's both efficient in terms of distributing the computing load and also statistically powerful by increasing the sample size. The statistical power of your results can increase. So what we're going to do next is have a look at an animation of how this works, which helped me when I first started DataSHIELD. So first of all, we've got, that's the DataSHIELD symbol. We're up in Newcastle in the UK. That's where we are. So we're going to look inside the analyst computer. That's me, the DataSHIELD analyst in Newcastle. That's the orange box. And then the data server, one of many around Europe, and there's one in the US, that's the blue box. So we're going to look at what goes on in each of those computers. So that's me, the stick figure, and I'm given the login details by the data custodian. So they will get to know you and know that you're a trusted researcher. So you're trusted with the login details. And then you write a script so that the login details get sent to the server and transmitted. And that authorizes an R environment to be set up on the server computer, which establishes the DataSHIELD session. So the session is that link between the two computers. So next, you might have a whole list of different commands you need to run on this data to find the answers to what you're investigating. And once it's all written and properly syntaxed and error-free, then you can send that. And that's usually built into the DataSHIELD functions themselves, the sending. Those go to the server, pardon me. And that's some cogs whirring, and the results are generated on that server. Now the server will check whether those results are overly disclosive according to all the checks written into the code of that server function. And then if it's non-disclosive, it gets to come back to you, the analyst. But that's just what's been going on one server. In many circumstances, we're doing the federated analysis. So you're also doing that command to lots of different servers around the world. So just like it's happened on that one server, the results are also generated on the different servers around the world, and they all come back to you. And now the meta-analysis can be generated by the function. So it will stitch together all of those different answers and can provide the aggregate result across the studies that you've connected to jointly. So yeah, that is the animation. So hopefully that helped you see where things are going and why things are moving around. Some other things to quickly mention are that DataSHIELD is open source. The key implication of that is that it's free to use and that it uses the R language. Just to note, our code is freely available through GitHub. And the analyst sends commands from an R session on their computer using DataSHIELD libraries, which you'll have to install. We'll cover that. And then you will receive the non-disclosive results. So that's it by way of explanation. We're just going to dive straight into the actual practical element, and you'll see me doing it. And then after we finish the session, it's all there online. I'll link you to the demo script and you can have a go yourselves and get real hands-on experience. What we're actually going to look at in our practical demo, it's going to be a data set of Titanic passengers, which I think we sourced from Kaggle. So this is quite suitable for a DataSHIELD analysis because it is individual personal level data, which if Titanic had sunk in 2012, then there would be confidentiality issues around that. Since it's 1912, obviously all of that is well out of date, but it's a good analogy. And so we randomly split the CSV that we found into two parts. So one is about 444 rows and the other is 447. But that could be similar to if the English people had bought it at the English ticket office and that ticket office had built a data set there. And then the French passengers had bought theirs at the French ticket office. And so then there'd be two different data sets stored at different places. What we'd be doing in that situation is not moving those data sets, but accessing them remotely. So let's go to our studio. So new share, Newcomers workshop. Our studio. So can you see that all right? In fact, do you want it a bit larger? I can make it.
Yeah, that's fine. Yeah.
So firstly, we did have a question this workshop, I think, asking whether our studio is necessary. It's not necessary, it's just the way we find convenient to run R. So I believe I'm correct in saying RStudio is the API for the R language. So if you like, you can use a more basic form of R or access DataSHIELD, as long as you've got the R language on your computer. And a bit more admin, I'm using a markdown script rather than just a regular R script. So this allows me to have explanations and then chunks of code. So if you want to run any R code, say we want to run this one, well, I won't run this one, but I'll run this one, then all you have to do is press this green arrow for run current chunk. It will only run that, it won't go through the entire script. So, understanding the concept of DataSHIELD, we've gone through the online presentation. So, getting ready in R, as I said, DataSHIELD uses R libraries, so you will have to install those libraries. I won't do it today because it'll take quite a while and that's a waste of demonstration time, but you will have to do this if you've never had DataSHIELD on your computer before. So that'll take 2-3 minutes maybe, depending on your computer. And then after they're installed successfully, you'll have to load them into this R session by using library. So I just did that, but you press the green button here. Just an aside, if you do have any questions, I will pause at several points through the demonstration. But if there's anything you're burning to ask, just type it into the chat box, and my colleague Dimitri is monitoring that and he can flag it up if it's something that needs to be addressed straight away. But yeah, I will pause and we can discuss things at certain intervals. So continuing on. The next thing to do is to log into the server that we're using today. What we've done is put this data already onto a server that's actually in France. That is the Opal demo server. So these are the credentials you need for that. You can go to this website, which is the Opal online portal, which is a resource that you use to look at the metadata of what you're trying to study. So let's do that now. I will go to new tab, and then the username is user, password is password. Yes, it is. So you sign in. And you see this dashboard. So the thing we'll want to do is explore the data, this data symbol here. And we'll scroll down to Titanic Newcomers workshop, which is the data set of the project we'll be studying today. And then within a project, you get several studies. So we have Titanic Server 1 and Titanic Server 2, which, as I said earlier, have just been arbitrarily split down the middle. Very similar number of entities in each. And what else can we learn about these? Well, if you click into a particular study, you won't get to see the data, of course, that's the whole point of DataSHIELD, but you will get to view the metadata. So, so there's going to be several column headers for the thing we're studying, but some of them don't make much sense, like SIBSP or whatever that would be pronounced as. You wouldn't be able to just know instinctively what that is. So you'd go here to the Opal portal and then read the metadata label. So that actually means the number of siblings or spouses that person had on board the Titanic. Some of them are just numbers, some of them are text fields, and some of them are, well, categorical variables. So you can only take the values 1, 2, 3, for example. This port of embarkation is I think that's set up as a text factor. But anyway, that means where they boarded the 3 ports that Titanic docked at before it sailed. So that's a brief overview of the Opal portal. I now go back to our studio. So the first thing to do after getting DataSHIELD set up is to actually log in. And we're going to use the same URL as what we just visited to get to the portal. But instead, it's just going to store the credentials to actually access the data in the Arch session. So this looks quite complicated, but it can be broken down into this part, which is just where you set up the builder object locally in R. That's a local R object, I should say. And you're using this new DS login builder with just one argument set. So that's that. Line 66 is that part. Lines 67 to 68 is logging into the first data set. No, is logging into the project. And then the second one, sorry, I've got myself confused here. Line 67 to 69 is logging into the first data set. So that is project name in capitals, and then study name in lowercase and separated by a dot. So that corresponds with how it looked on the portal. And then line 70 to 72 is logging into the second study, which is Titanic Server 2. Don't worry about having to remember this. It's in lots of places online, such as on the wiki and in example materials for this workshop and stuff like that. So you can just copy and paste this whole chunk, and then you'd go in and change the URL to whatever URL you needed, change the username to what you've been provided, password similarly, and the project and study names. So it's just something you can customize. And then that is something that is built and stored locally. So I'll run that and it's stored locally. And then we'll actually run the connection. So it uses this function, datashield.login function within the DSA package. We just do that to save any errors or confusion. and it has these arguments. So firstly, you need to specify what you're going to call the login information for the connection. Secondly, whether to actually assign data to your connection. And thirdly, what symbol to call the data. Here we've just gone with D for DataSHIELD. And when you run this entire chunk, that's when it actually goes away and goes to the collaborating servers and logs in. If it's a larger data set or you're on a slow computer, this will actually be a progress bar that will slowly load, which is useful to see that it's actually progressing, not stuck. We haven't told it to only load specific variables, which is an option you can explore in the DataSHIELD.login function. So it's just gone and assigned everything, the whole this is data set. So rather than just plowing on with everything going perfectly, let's try and run a mistake and see how to debug that mistake. So I'm going to run all this. And then that looks still in red, but it is not the same as it said before. So what is the key thing to read here? Will be this will be excluded because this is not accessible. So that sounds to me like we've got the table or study name wrong. So have to go up and search through your login builder and see I have put the wrong study name, wrong project name, I should say. And so what we'll need to do is change that to the right one, which is Titanic Newcomers workshop with underscores. So once you put that in here, sorry. This is the part where I cross my fingers. There's something wrong with the first one as well. So that says Titanic Newcomers Dataset 1 is not accessible. Because the actual study name of the first one is wrong. So I'll copy and paste that and then change 2 to 1 and then run it again. And then it succeeded. So that's just hopefully a useful illustration of how to read the output of a failed login and bug fix it. So now that we're in, well, what to do? Well, firstly, we need some idea of our data. We have got a kind of tiny illustration of that from the metadata we viewed online. But there's obviously a lot more we could do with knowing about. So firstly, the dimensions is a good one to know. Let's look at an actual DataSHIELD function for the first time. They are all prefixed with ds dot, so ds for DataSHIELD. And then the second part is that actual what it's going to do. So dim is similar to the dim function in regular R, which is for dimension. And in several cases, the DataSHIELD function is very similar or the same as the base R function, so after the ds dot. But you can't always rely on that, so you can't just go, I don't know a good example, but you can't rely on that, so you will have to check the exact name of the DataSHIELD function that is doing what you are trying to do, like variance or covariance or whatever. So let's have a look at the help function. That's done by doing the question mark in front of it for the non-R users. And that goes away and finds the help documentation. And we're given what it does, the default arguments, more information about how to customize the arguments. So what is X, how can you change the type to combine or split, what checks it has, and what data sources you need to put. So yeah, that's just a list of a complete list of what you'll find in the documentation. Not all of it is relevant here. So let's actually use it and get some aggregated results. So I will run just that first line by doing Control and Enter. We'll see the results printed here. So this is telling us that in the first study, there are 444 rows, 11 columns. In the second study, there are 447 rows, 11 columns. And then it will tell you the combined result. So that's aggregating the two together, which says 891 rows and 11 columns. So that all makes sense. But what does adding this data sources connections do? Well, firstly, it's good practice. It makes sure that your local answer session knows exactly what you're connecting to. Say if you did multiple connections at once. But also it means you can customize exactly what you're looking at inside the particular project. You can look at only the first study or only the second study. So what if we do with this square brackets and look at only the first study? So then it's only printing the first study's results and there's nothing to aggregate, so it's the exact same thing. So that's a quick look at how to customize what you're accessing using the connections, data sources connections argument. Are there any questions so far, Dimitri or Elaine?
Not on the chat, but maybe we can ask if anyone want to ask anything.
Yeah. Well, I'll be stopping again soon, so if you do think of anything, do is that
We have one question. Is it possible to see all tables from R? What do you mean? Do you mean all the tables that you have on the server? Yes, basically there is a function which is called DataSHIELD.tables, and when you put inside brackets the name of your data sources, which is in this case connections, you can see all the tables that are available in each server. I will put the command on chat.
Shall I run that now, Dimitri, and see how it looks?
Yeah. If you
So I'll copy that from chat.
as you can see in this server, in server one, we have all of those tables, but we actually log into the bottom to the number 19. And if you go down, Alex, in the second part, we have the second server. And again, we have a lot of tables in the second server, but we only use in that session the Titanic server 2. And in the same session, you can assign multiple tables.
Yeah. So just another quick thing to show you before we go on showing off DataSHIELD functions is what functions there are to use. So I will go to Chrome again, and then to the DataSHIELD website. and then to support. So this is the way in if you want to quickly find helpful resources. And I'll stick that in chat. Anyone who wants to go. What I'm going to go and look at is the link to the list of analysis functions, which links through to our wiki. And here there are the complete list of various DataSHIELD functions available, and they've been grouped. Obviously, this isn't the only way to group them, but it's quite useful if you want to say, well, I want to do some summary statistics, then you can go down to data analysis, and then within that summary statistics, and you've got DS mean, mean by class, quantile mean, variance, covariance, correlation test. So yeah, you get the picture. This is, if you're wondering what you can do, this is a good place to go. And I'll just reiterate, it's DataSHIELD homepage, then support, then scroll down here to DataSHIELD analyst section of the page, and it's list of analysis functions. So back to our studio one last time. So some more functions in the data exploration phase is, for example, column names, ds.column names. And here we actually need to use the arguments. So firstly, x. Well, let's look at the help function first of all. What is x? X is the character string providing the name of the input data frame. Well, we remember when we logged in, we called the input data frame D, and we'll use that, but also remember to put it inside quotations. That's really important because it is being transmitted to the server as a string. So if you don't put those quotations around it, it will get very confused and throw an error. The only one that generally doesn't need to have those quotations is the data sources argument, because that's referencing a local object. We've got the connections here that you set up. So let's actually run ds column names. Well, that tells us the column names as you'd expect, and it's what we saw before on the data dictionary. So yeah, if you were confused at this stage, hadn't looked on the portal already, then this might be a time to go there to work out what certain ones of these are. But for now, we're just going to use obvious ones like passenger class and name and sex. So this is just a text explanation of what I showed you before about the Opal portal. So here I'm just describing what not to do, just reminding you that you can't directly view the data. That's the core functionality of DataSHIELD. You're meant to analyze the sensitive data without viewing it or deducing any revealing information about it. It is a change from what you might normally be doing in R, and it certainly was when I started programming in DataSHIELD. But it's a challenge that you will start to get used to, and will start to use the roundabout ways to find the information you're interested in. So what I always used to do in my analyses in university was look at the head of the data to see what the values in the first 10 rows or whatever it was looked like. Of course, that's not allowed in DataSHIELD. That's sensitive information on 10 different study participants or that nature. It's private information. So you need to get the gist of those numbers by doing, I don't know, mean or the variance or that kind of workaround. Are there more questions?
Yeah, basically I want to reply to Philip, not on the chat because it might be easier. Actually, in a real setting, the two Titanic tables will be stored in two separate servers. For simplicity, for this workshop, we put both tables in one server but we assume that we have two different servers. In a real setting, when you have two different servers or more, you cannot combine the tables. It's not possible to pull the data in one server. But the functions, the way that we are doing the functions, we get summary statistics from each server, and depending on the command that we send, and then we aggregate these summary statistics on the analysis on the client side. For example, if we want the mean of a variable, that this variable is stored in 3 different servers, and it's a variable for different participants, for 3 different cohorts, for example, we get back from the command that we send to each server, we get back the sum of the variable in that case and the number of valid cases. And using this information from each study, on the client side, we calculate, the function calculates the combined mean. And depending on the command, for example, if we want to do generalized linear modeling, we have 2 ways, either to do meta-analysis. In that case, we get the final results from each regression, from each cohort back to the client side. And then we meta-analyze those results on the client side. Or we have an alternative way, which does a full likelihood regression. It's through an iteration process. And the results that you get at the end, we have an algorithm, but without physically pulling the data, we get exactly the same results at the end with the case that we are able to pull the data. So these are the 2 types of techniques that we can use in DataSHIELD. So the next question, if it's always we have to do a 2-step meta-analysis. No, we can do also one. At the moment, for regression with fixed effects models, we have function that we can do 1-step analysis. For mixed effects models, we don't have the function yet, but we are working on that development. And for all the other descriptive statistics, you can get the study-specific results and also the pooled results. I hope that I answered your question. Okay, great.
Great. So this is just showing you again that complete list of functions in case you want to directly go from this link when you're looking at it later. But let's look at the built-in command that does the same thing. So that's DataSHIELD.list client-side functions. Don't need an argument there. And this lists the DS-based client functions. That's just every single one down to 101. But obviously they are not sorted, so you might find the online list slightly more helpful in that respect. So continuing on, let's do some actual, just looking at the values and working out what this data set is about. So how many missing values in a particular column? Well, we have a function for that, which is DataSHIELD.number of NA. And we'll do that to look at the age column. So we're going to reference the data frame, use the $ notation to look at a particular column like you do in base R, and then put the quotations around it so it transmits in DataSHIELD. And then finally use this argument data sources to tell the local DataSHIELD session which connection to go through to the right server. And so I will run that. So that's telling us the results from each server. That's 87 missing results in the first server, 90 missing results in the second server. And to compare that with the actual length of of that column. So again, we're going to use the DataSHIELD.length function that speaks for itself, makes sense. The object argument is going to look at the same column, d$age, and also look at the same connections object. And that's what we got before from the dimensions. But now what we can do is do some deduction and work out the number of non-missing data from each server for age. So we're going to do, well, taking the results directly, 444 minus 87 and 447 minus 90. And then we print those two results. They're the same. That's just random chance, I think. There is a different data shaping function, which doesn't do the same as what we did above. It doesn't just look at one column that has a missing value. It looks at every single column that has a missing value and pulls them out, leaving a data frame where every single row is complete. So let's see what it does here. Firstly, looking at the help function. So selects only the complete cases of a data frame, matrix, or vector. What are the arguments? So x1, well, as always, that's going to be the input object. And then here we need a new obj. So that would be in cases where you wanted to create a new object on the server side. Obviously, you can't create a new subset data frame and pull it back to you, because you'd then be able to look at the values contained within. So instead, you would save it to the server side. But we're not going to use that here in this case. We are going to clarify the connections object and run that line. So because we didn't specify the name, it came up with a default name on the server side, and that default name was d_complete.cases. And this message here is just telling us that, which is obviously very useful. Otherwise, we wouldn't know what name to reference. And a validity check is also run. So because we haven't got an actual results object back, we're going to refer to this from now on as an assign type function. Assign type because it's just gone to the server and assigned and stayed there. But the opposite of an assign type function is an aggregate type function. Aggregate as in it's gone to the server, generated a result, and that result is kind of aggregated from the data available, but not actually containing disclosive values, and it comes back. So that's the key way to remember it, is assign stays on the server, aggregate, there is something that comes back to you. So let's actually look at what the dimensions of d-complete cases, that new object that was just created, are. So we know before it was 444, 447. It's gone down to 87 and 96. So that's a whole load of data in rows has been stripped out. So it may be the case that we don't actually want to run complete cases in our analysis of this data set because too much data is lost. So are there any questions at the end of that coverage of assign and aggregate type functions? I see you've already answered some, Dimitri, yes. So unless there's anything else. Also, feel free to unmute and talk if you want to in our breaks. Quite happy to take questions that way too.
May I raise an issue, Alex?
Mm-hmm.
Yeah. So I'm a member of a EU consortium, and I've seen that other members of the same consortium are also attending the session. So I'm a member of a Respond consortium, which is looking at how to analyze several data sets from different members, and these data sets are likely to be located indeed in different servers. But the interest of DataSHIELD for me would be whether the kind of statistical analysis I'm thinking of is available in DataSHIELD. Is that the first thing I should check? Let's say that I'm interested into a logistic mixed model. Before getting started, I should check whether the function is available in DataSHIELD. Is that the way forward?
Can I answer, Alex, on that?
Yeah.
This is the way that you can look forward. And if you do that at the initial stages of your projects, then if something is not available, we can develop that. Either in collaboration with you, if it's a specific algorithm, or if this type of statistical technique already exists in a native R package, then it's quite easy for us to implement that in DataSHIELD. We need to add some disclosure controls and stuff like that. But this is the way. For example, because I see some people from the lifecycle project, some people, they requested functions to do mediation analysis. So a few months ago, we developed another DataSHIELD package to allow the users of that specific project to do mediation analysis. Yeah.
Okay. So to move on after that, we've worked out what aggregate type and assign type functions are. So looking at exploring some discrete data, we can first of all look at what class a particular column is. So ds.class, DataSHIELD.class, that's going to print out what class it actually is. That's an aggregate type because the result comes back. So we're going to look at the object x equals the data frame D, column embarked, put it in quotations, and reference the connections object and run that. Okay, so it turns out embarked is actually set up as a factor. So that could be interesting to try and make a table of it, because tables in DataSHIELD have to be run on factor type data. So the first thing you do when using a new function like this would be to run the help to get the documentation. And so we can create contingency tables, either 1, 2, or 3 dimensional. So this is all of the default values. So the fact that it's null, null, null means if you just run it without anything in the brackets, it will throw an error. So we will need to read the arguments to work out what goes in. So you fill it from top down. So if you just want to do a one-dimensional table, you'll have to fill R var first before filling C var, for example. So if we do a table on the embarked column that we just worked out was a factor class. We'll set up DataSHIELD table with, that should actually say rvar equals. It will work it out by being the first argument, what it is, but it's always best to be clear and make sure the DataSHIELD function is doing exactly what you expect it to. And then here in the connections, we're not just doing the default connecting to all of them. We'll only look at the first connection object, which is the first study. So run this. So firstly, you get the validity check and no errors. And then we're going to look at row proportions. Doesn't make much sense because everything is full. So that's like 100% of Southampton borders in Southampton. So that's the table you can ignore for the purposes of this investigation. This is where it actually gets interesting, looking at the column proportions. So there's the col dot props. And so here we can see that actually 72% bordered in Southampton, 18% in Cherbourg, and 10% in Queenstown. And then we do have NA appearing for some very small number. And then as well as the proportions, you get the table by counts. And so by raw numbers, you can see there are 319 at Southampton on this particular server, 81 at Cherbourg, and 43 at Queenstown, but just one NA. So that explains why that percentage is so very small. The table function then goes on to portray the data in inversed. So this might be more useful for what you look at, but it's best to just like take the results of the table out and do what you need to do with them rather than rely on how the data is presented here, because there's obviously lots of printout here that you may not want to include in your results. So same results, and then finally validity message again. So that's a look at a one-dimensional table. What about a two-dimensional table? Well, we could compare the number who survived against the passenger class. So, oh, sorry, it's not the number who survived, it is the binary survived or not. And then, so that's a factor, and also passenger class, first class, second class, third class is also a factor. So that means both factors, therefore a table can run. Again, we'll get some validity checks, error reports, and then you dive into the actual proportion, the tables by proportion. And so we'll see that for those who didn't survive, reading it across here from the side, for those who didn't survive, 15% were first class, 19% were second class, and 66% were third class. And then it's slightly different proportion. Oh, no, sorry. Let's find that again. And from the top. So that one was row proportion, so you're reading across the rows, whereas this output is column proportions, so you're reading down the columns. So here you would read that of the first class passengers, 42% did not survive, so that's a 0 for survived, and 58% did survive. And then similarly, you could read down for third class, 71% did not survive of third class, and 28% did survive of third class. So you really have to pay attention to what these are called to not get confused, because obviously if you read across on this, then it sums to more than one, and doesn't make much sense. So So that's looking at just dataset 1. You also then have the same again for dataset 2, or study 2 that you've connected to. And then you get the proportions for the combined studies. So as well as looking at the individual studies, the DataSHIELD function has aggregated them for you if that's what you wanted to find out. And then it does it all over again with counts. So counts for study 1, counts for study 2, and combined counts. So that's your contingency table. We'll just quickly look at the chi-square tests, since I think we've got. Yeah, so I'll run the help function for table. Get that. So we'd want DS table with R, for example. But then if we did want chi-square test to be run, then we'd use this argument, but change a false to be true. And then obviously you'd fill out connections and what the R and C would be. And then you'd get printout with all of the above. Let's actually run it. These sources equals connections. Going through it again, all of this is just what we saw before, exactly the same. But then after the final validity message, then you go on to the chi-square test, and here you get the statistics that you may need. So degrees of freedom, p-value of the chi-squared statistic. And then it's also by study and then combined. So that's lots and lots of different things that you might find useful out of a table function. But similarly, we haven't shown you all of the different functions available. You'd have to go through the list yourself and find exactly what you were interested in for your data. So on to descriptive statistics. Let's look at the column names again as a refresher. So 5, passenger class, name, sex, etc. And then what is the mean age of the passengers, for example? Let's have a look. So this has got the mean age of the first study, so slightly younger in the first study than the second study. But that's a bit meaningless without the variation in those names. So ds var x equals d $ age. So quite a lot higher variance in the second than the first, so that's interesting. And then we can look at the median and quantiles. That could be useful for looking at spread. So there's this particular function called quantile mean, DataSHIELD.quantile mean, and we'll run that line only. So we'll look at it, but notice that it's the quantiles of the pooled data. So the way to actually look at each study by itself is to add this argument here, type equals split, and that forces it to do a separated instead of combined results print. So I run that line, and here we see, yes, again on the first server, for each quantile, the age is slightly lower. That's obviously just going to be a quirk of the data for how we separated it. So we do have graphing capabilities in DataSHIELD. I'll use I'll show you the first one here, histogram, and then Dimitri will show you some more different types. So histogram will be useful to look at the age and see if it reflects what we found out about the spread and the central tendency from the functions we have just run. So we're going to look at the age object and combine them, run just that. So here's the histogram of the pool data. Obviously the peak is around age 20 to 30. And then if we wanted it split instead of combined, we'd remove this type because the default is split for that argument. And you would come up with this printout. So obviously you could cut and paste and compare, but if you wanted it to directly print, if you wanted it to print one on top of the other, the way to do that would be to use ggplot, and ggplot is possible, I think, for all of our plotting functions. You just use the numerical return from the server instead of directly plotting. That's not something for a beginner session. There are instructions online and in other workshops to show you how to do that. So if I can hand over to Dimitri to show you some more graphs. Dimitri, do you want to do it on my screen or on your screen?
I will request access to your screen.
Okay, there you go.
Yeah, basically, we can't do the last part quickly because it's important to have a discussion, I think, at the end. I want just to show you an example with the scatter plot function, because the graphical functions are dealing with the data slightly different than all the other statistical techniques. And this is the reason for that is because if we display the data in a scatter plot, the coordinates in this scatter plot are the actual values of two variables, and these might be disclosive by definition. So what we are doing in the graphical functions, we slightly change the actual values of the data that we want to display. We anonymize the data, but in a way, we anonymize the data in a way that we keep the statistical information that we want to see in the graphs the same as if we plot the real data. And for the scatter plot, for example, we have two main techniques. One is addition of random noise in the 2 dimensions that we have here. And the second technique is what we call deterministic anonymization. It's an algorithm that we have developed, where if we imagine the data points in a 2-dimensional space, for each data point, we search for k-nearest neighbors. And for those neighbors, we calculate the centroid and then replace the coordinates of each point of interest with the coordinates of this centroid. I will not give details on this algorithm, but actually minimizes the risk of disclosure and also minimizes the loss of information that we get from this anonymization procedure. So I will run this. Oh, okay. Let me run the second one. Yeah, basically this error message says that we haven't specified the data sources. We haven't added this argument. And if we do it on this line here, we can see the specific scatter plot. And here we did a plot of fair against age. We don't see a strong correlation, but this is the structure, a similar structure that you can see if you are able to plot the scatter plot for the real data. And we have also a wide range of graphical functions. We allow heat map plots, contour plots, box plots. You can see the list of graphical functions in the link that I put on the chat. Another feature that we have in the graphical functions is that with a specific argument, you can extract the coordinates of the anonymized data back to the client side, to the R studio that you have here. So it's like you transfer anonymized values from the server to the client, and then you can use any native R package to do any graphs that you want with this anonymized value. And one example that Alex put in these notes is that you can use, for example, ggplot. So this is about the graphical functions. And the last thing that we have in this script is a function that is included in DSI, where anyone can save a workspace on each server. So in the same way that we have an environment on the client side in our studio here, and we can see all the objects that we created on the client side, the similar environment exists on the R Studio that is installed in each server on the data server. And the objects that we create on the server, we cannot see those, are not displayed on the client side, but we can, for example, when we did the table of complete cases, this table was stored in each server. We obviously cannot see this table, but we can save it. And if we want to log out from this session and come back later, we don't have to run the whole script from the scratch. We can restore the saved workspace and continue our analysis from the point that we left. So this is the command that we save a workspace, datashield.workspace_save. We need to specify the name of the data sources, which is connections, and then we can give a name to the workspace. If you, in the next time that you save a workspace, if you use the same name, it overrides to the previous name. So in some cases, it's good if you use different names. On the other hand, it's not good if you save a lot of workspaces, because they use some space from the server, and if you have a lot of users, it might create some problems. So usually it's better if you use a specific name of your workspace and come back to this at a later stage. So this is the command. We can save the workspace here. We can log out from the connection. So now we don't have any, we cannot use any functions, any DataSHIELD function now, because we logged out from the data servers. And if we want to continue our analysis, instead of logging back to the servers with the initial, with the first part that Alex presented today, with the builder and the DataSHIELD login, we can again use the DataSHIELD login, but here we can use the argument restore and specify the name of the connections or of the workspace that we specify in this function here. By the way, we need to change this date. It's a typo. Yeah, so if we change this to the name of the workspace that we had saved, yeah, 0.6.9. We can log in back to the servers and continue our analysis from the step that we stored this workspace. And the other thing that is important is this function here when you have to log out from the connections, because again, it will not affect, if you are logged in, it might affect the memory size of your server in a way, and it might affect the users. If you have a lot of users, if you are a small project with 20 users, for example, this is not a problem. Yeah, that's it. So we can, Alex, I'm not sure if you want to show anything else before the.
Yeah. So yeah, thanks for watching. If you want to have questions, we're going to do that until 11 UK time, 12 European time. But please could we ask you to just do a short 2-minute survey on how you find today's Newcomers workshop. So I've got a QR code to go to SurveyMonkey, and there's just very simple questions, and it'll be incredibly helpful for us to fine-tune this this presentation for future attendees. So yeah, we'll just give you 2 minutes for that, and then it'll be on to questions. And yeah, and
can you put the link on the chat, Alex?
yes.
And I might answer the questions that we have on, or do you want me to wait 2 minutes?
Oh no, I'll get it in chat. There we go. In chat.
Okay.
Yep.
So basically, I want to answer 2 questions that we have on the chat. One from Patrick: can you get a list of all saved workspaces on the server accessible to you? So this command that I put on the chat is the command that you get this list. And the other question by Vicky: what about raw data sets where you need to pre-process the data before any analysis? So if you are a project that you have horizontal partition data, for example, multiple cohorts, and you store these cohort data in different servers, one big step before the use of DataSHIELD is the harmonization of the data. And this should be done outside DataSHIELD. And this is, it needs some time, and you need to think how to do that. And for example, I will give you an example. If you have in your data if you have in the questionnaires a question asking, for example, something about smoking, and in some countries they ask, do you smoke? And the answer is yes or no. And in some other cohorts, they ask how many cigarettes you smoke per day, for example. So if you have these 2 different types of questions in 2 different cohort data, they have to harmonize the data before the uploading to their servers in order to use DataSHIELD. And this is necessary as a step before that. And the other thing that is important, in this example about Titanic data, you saw a column name which was related to the actual name of the individuals that they were on the Titanic. But the good practice that most of the projects do, they do what is called pseudonymization of the data, which means that they remove the direct identifiers like the name or the real ID, for example, if it exists, from the data before uploading those data to the server, because you don't need in most of the cases, the name in the analysis. And usually they create a pseudo ID for each participant. And this is what is used because in some cases you need this pseudo ID for some specific type of functions, like if you want to merge two tables on the same server, then you can merge the tables if they share a common ID, for example. And just curious, what happens if you request sensitive information? Yeah, if we don't have this function. For example, if you want the head of a data frame, we don't have a DS head function. It's blocked, and we have a lot of layers of protection in DataSHIELD. For 3 different parts. One part is about the architecture. As you, I don't remember if Alex told in this presentation, DataSHIELD, in this animation, you saw that we have the analysis computer, which also is called client side. And on the client side, we install the client side packages, for example, the DS-based client. On the server computers where we store the data, we have again another RStudio or R there, and we install there the cohorts or the data managers, install there the server side packages. So in that case, there is a DS-based package. So the user cannot do anything, cannot do everything. They have to use the specific functions that we have, and the communication between the client and the server is done in a protected way. And there is also an R parser which blocks any commands that we are not allowed, or if you specify a specific, for example, if you have a formula with a specific symbol that is not allowed from this parser, then you get an error message. And we also have disclosure controls on the server side. We check what is returned back. We have a lot of protection layers in DataSHIELD. Alex, can you share the code?
Yes, I am uploading that right now, and then I'll paste the website into the chat in 2 minutes.
Files or RNA, like row here that you need to create in case of RNA sequence. Yeah, basically, yeah, I'm not familiar with analysis of genetic data, but we have collaborators in IS Global who developed the DSomics package, and you can have a look there. Maybe there is functionality that you can process the data within DataSHIELD, but I'm not sure to answer your question, Vicky. Sorry about that.
Okay, going in the chat now is the link to the Newcomers workshop page on our website. So that's got useful links there, the analysis script, and I'll update that vignette notebook printout of all the code and code chunks and the presentation slides in the next 5 minutes. In the next day on that web page, you will see today's workshop be uploaded to YouTube, and we'll put that on that page as well if you want to review the session and hear the explanations again. So yeah, that's just the DataSHIELD homepage, then support, then on the drop down, get started Newcomers workshop, or just save that link.
Are there any other questions?
Yes, I'm just wondering if you have a number of examples of effective use of DataSHIELD across different sites, different universities or research institutes. Do you have I would say, good examples of that kind of use. That would be my question.
Yeah, basically, I'm not sure if Alex, we can put in our website, we have the list of the consortia that they are using DataSHIELD. We have mainly we have big European consortia like You Can Connect, Life Cycle, the Athlete Project. We can put a link to that. But and in those, for example, each of those projects, they use cohort data across most of the countries of Europe. So they have between 15 up to 30 cohorts each consortium. And you can also, in our website, you can see a list of publications where they describe actual analysis in DataSHIELD. Yeah, You Can Connect, for example, it's a consortium that they want to, the main task is to develop infrastructure, but they have also the analysis, work packages, and they want to analyze data that are coming from Europe and Canada. Athlete and Life Cycle are mostly focused with European cohorts, but they have also some external cohorts from Australia and Canada, I think. And we had also other consortia in the past, like Big Bioshare to analyze the healthy obesity in Europe. And the other one to analyze the environmental effects on health. We had the NPANDASI, which was a project in Germany, but was analyzing different cohorts in Germany, and the data were related to nutrition. We have the Interconnect project. I don't remember where it is. It's based in UK, but I don't know the cohorts that are involved, where they are coming from. Yeah, we have big consortia, and they are quite good use cases. Where are you based, Vincent?
I'm based in Belgium, close to Brussels.
Okay.
So I'm a member, as I said, we are a member of a Respond consortium. Well, the question I have is also whether you think that DataSHIELD is more effective where the data have been collected with the same protocol, let's say the same questionnaire in different across different countries or across different sites, and then you use DataSHIELD as a way to analyze the more or less the same kind of data set, or do you think it can be also useful where the data set have been collected under different protocol, different schemes across sites or countries? Because these are different situations. Sometimes, you know, the same questionnaire has been collected in different countries, but this is the same format of the data.
Yeah.
And sometimes the data have different format or different schemes underpinning the data collections.
Yeah, in the previous use cases, we had both of these settings, and also we had a third one where you and a registry or anything collect data in one site for one cohort, but they don't want to share this data even with their researchers in their own institution. So they use one site, DataSHIELD, to analyze data remotely without seeing the data. And yeah, but we had users in both cases that we described.
Okay, I think I'll stop the recording.